Hi there, this is Mr. Coumbe. Let's do another gas stoichiometry problem. So here, pause the video so you'll be able to actually read the question, and I'll see you back in a second. Okay, so in this particular question we have acetylene gas. First off, let's do the equation. So let's make an equation. We have acetylene gas, which is C2H2 gas. Beautiful. And we combust that. So if we combust any combustion reaction, we'll need oxygen. When we combust that, you'll produce carbon dioxide gas and you'll produce water vapor. And the water vapor is going to be gas. First thing we need to do is we need to actually balance this equation. So on the left hand side we have 2 carbons, so we need to at least double this. But here is our little dilemma, that we have this one here that is a single oxygen. So that's being an odd oxygen. I would already sort of double that. If I double this already, then I'm going to have at least a pair of oxygens, because you only have pairings over here. So if I double the oxygens, you're going to have a pair there. So I need to, now I have 4 hydrogens, and here I only have 2. So if I double that, I'm going to have 4. Here I have 4 carbons, so I have to multiply this by 4. So here I have 4 O2s and have 1 more O2, making this 5 O2. Okay, beautiful. Now, so how many liters of acetylene are we going to need if we have 75 liters of carbon dioxide? So let's have a look at our molar ratio. Because remember, when we have gases, their molar ratio, the ratio of the volumes will be the same as the ratio of the moles in the reaction itself. So for every 2 moles of acetylene, you're going to need 5 moles of oxygen and produce 4 moles of carbon dioxide and 2 moles of water. So our volumes then, so if we start off with here, so I'll put it in orange, if we start off with 75 liters of carbon dioxide, then the ratios will also be the same. So I'll do this the longhand way so that you guys know how to actually calculate it. So we have to compare all these ratios with the ratio of what we do know, which is carbon dioxide. So first off, how much acetylene are we going to need? So C2H2. So if we compare these two numbers, for every 4 moles of carbon dioxide produced, you only needed 2 moles of acetylene. So the volume of our acetylene, C2H2, is going to be 4 over 2. Oh, I apologize. It's going to be 2 over 4. Sorry, 2 over 4 times the volume of our carbon dioxide. Okay, because so that essentially becomes a half. Okay, so the volume of our acetylene is going to be half of 75 liters, which is about 37.5 liters. Okay, in question B, how much water is produced? It's going to be the same as acetylene, because the number of moles of water produced is the same as acetylene, so that's going to also be 37.5 liters. Now with oxygen gets a little bit more complex, so the volume of our oxygen is going to be 5/4 of the volume of what we do know, which is carbon dioxide, and that is 93.75 liters. And there is your answer.